Hello and welcome to this video. In this video I would like to show calculations on the return of single stocks. For this video I planned the following. First of all, I would like to define prices and I would like to calculate simple daily returns and daily log returns. And then I would like to discuss the reasons to use log returns. And then we're going to calculate mean daily returns. And we're going to annualize mean daily log returns so that we can compare annualized returns. Well, what we see here is typical price data from the stock. So here we see the adjusted close price. The adjusted close price because it is adjusted for dividends and other stuff just like stock splits. So here we see Adidas from Germany and Deutsche Bank and Vonovia, and Adidas has some €268.94, then €268.40, and so on and so forth. Deutsche Bank the same but a lot smaller, and Vonovia. And we see the days. T is 0, T is 1. Of course we can put a date here, but we need to denote the time as T. And we need to denote the stock as with an S. S is 1, S is 2, S is 3, so that we can use different stocks here. Accordingly, each of these prices is denoted with a capital P for price and a lowercase s and a lowercase t for the stock S at time t. Now the simple daily returns are given by simple percentage calculus, and they are denoted with dr, daily return of stock S at time t. If we now look at, let's take this one here. Oh no, let's take this one here. So Vonovia at time is 1, it is 0.0170, which means that Vonovia has increased by 1.7% between day 0 and day 1. Of course, this return is put into day t is 1, so that for day 0, since we are lacking a comparison, we have an A, we can't calculate that for 0. Since these are closing prices, of course all this happened on day t1 and not on day t0. Accordingly, this is the simple daily return of t1. Now, how do we calculate this return? Well, dr as of stock S and day t is defined as the change in prices, so the price of, let's say today, as of stock S and day t, minus the price of yesterday, so it's still stock S but t minus 1, and normalized or divided by P as t minus 1. So the percentage change between yesterday closing price and today. Or equivalently, the price of today divided by the price of yesterday minus 1. And if we now put some numbers in, I just go back to the other screen. So we need this price, which is yesterday's price, and we need this price. It is today's price. So we will have 41.72 minus 41.02 divided by 41.02, or equivalently 41.72 divided by 41.02 minus 1, and that is 0.0170, or in other words 1.70%. So that's simple daily returns. Let us denote the daily log returns as R of stock S at time t, so without the D, and the daily log returns are defined as R as of stock at time t is the logarithm, the natural logarithm of the price as of today divided by the price as of yesterday. Or, applying the logarithm calculation rules, the difference between the logarithm of the price today and the logarithm of the price yesterday. Or it is simply the logarithm of 1 plus the simple daily return. Okay, if we now put some numbers in, we can calculate the natural logarithm of the price 41.72 divided by 41.02, or the difference in logs and that is 3.7310 minus 3.7141, and that is 0.0169, or equivalently 1.69% stock price increase. So, what are the reasons to use log returns? As we have just seen, the log returns and the simple returns are quite close. If we just go back, we see here 1.69% and we see here 1.70%. This is true as long as these returns are very small. So the logarithm of 1 plus the log return equals the daily simple return as long as the return or the daily simple return is very, very small, so far below 1. The second reason is if log returns are assumed to be normally distributed. You all remember normal distribution, right? Normal distribution. The prices are log normally distributed. How does that look? I take another color here. So a log normal distribution looks something like this. So prices cannot become negative. And that's quite a positive assumption here because it reflects reality a lot. Time additivity is another reason to use log returns. So consider that there's an ordered sequence of days. Let's denote them day. We already did that, of course. Day 1 to day t. This is our ordered sequence of days. And accordingly, if we take the simple daily returns, we have to calculate 1 plus the daily return of day 1 times 1 plus the daily return of day 2, and so on and so forth until we end up at the last day, or we simply take the multiplication sign. So this is the multiplication sign. It's mainly equivalent to the sum sign, but we multiply and do not add up. So here we multiply all the numbers t for 1 plus the daily return. But this is very unpleasant because the product of normally distributed random numbers is not normally distributed. So statistically, we run into trouble here. The sum of normally distributed random numbers is normally distributed. So it would be very, very nice if we add up returns. If those returns would be additive, it would be very positive for us to calculate with it, as long as those returns are not sequentially uncorrelated. Okay, that's fine. So what does that mean? It means if we calculate the logarithm of 1 plus the log return, that is mainly the logarithm of the price today divided by the price yesterday, we can put this as the difference. We already know that as the difference between the log price today minus the log price yesterday. If we do this for several days, just like the log of 1 plus the return for day 1, day 2, until here the k is wrong, it must be an r, of course, I'm sorry for that, until day t, it reflects perfectly the difference in logs for the price at day t minus the log of the price of day 0. And this is exactly what we're looking for. We're looking for a possibility where all those logs can be added and reflect again the price difference, or let's say the return as a price difference. So let's put this into an example. We take a look at Vonovia here, and we take a look at all the prices. So the log returns were already given by 0.0168, 0.0270, and 0.0108. And now we take a look at this price and this price. So the return between those two prices can be calculated simply by the natural logarithm of the newer price as of day 3 divided by the older price as of day 0, and that is 0.0548 or 5.48% equivalently. And now to prove that we can add up all those returns, we can now calculate the log of 1 plus the first, this one, 0.0168 plus the log of 1 plus 0.0270 plus the log of 1 plus 0.0108, and that is 0.0548, and of course that is 5.48% equivalently. So what can we learn from this? Here we have plus signs, so we can simply add up those log returns to achieve a longer period of time. The last reason to use log returns is that due to time additivity, what we have just seen, in combination with the central limit theorem, the central limits theorem says that under certain conditions, adding up random numbers leads to normal distribution. We have the wonderful effect that added log returns should converge to normality. Okay, if we now take an average, if we now calculate mean daily returns, it is well known that for simple daily returns we need to apply the geometric mean. What does that mean? That means here we have a simple daily return for stock as at time 1, so 1 plus this simple return times 1 plus the second day plus all the other days until day t, and this taking the square root, 1 divided by t is not the square root but the tth root, I'm sorry for that, the tth root minus 1 is the average return drs, no t anymore because this is the mean daily return, so we can skip the t here. Or in another writing, the tth root of the product sign of 1 plus the simple return and all that minus s. Well, we can sustain from this complex calculation due to the time additivity, and for daily log returns we can simply take the arithmetic mean. That's a lot less complicated here, so it makes life a lot easier. Of course, daily returns are not what we typically use. Typically, we can compare annual returns. Just like interest rates. Interest rates are annual return, so it is useful to annualize these returns. Now, for the annualization of these returns, we can apply two formulas. We can apply this, which is a compounding formula, and we can apply this, which is due to time additivity. But these formulas are obviously different. So this is the compounding formula for continuous returns. So if RS is meant to be continuous, so this is the mean return here, or the mean daily return. The mean daily return. So this one would be compounding for 250 days, and we get the annualized return then. Let's make a calculation on that under the assumption that RS is minus 0.01 or minus 1% equivalently. So if we do that, we will end up with RSA being minus 0.9179 or 91.79%, or minus, of course, 91%. Or in other words, if this company loses on average 1% a day after a year, 250 trading days, I have to write that down, I guess, 250 trading days. That's the reason for the 250. So after 250 days, this company will have lost 91.79% of its value. If we apply the same here, we will have minus 0.01 times 250, and that is minus 2.5 or minus 250% equivalently. Of course, 250% is complete nonsense, because a company cannot lose more than 100% of its value. So, which formula should we use here? So, if we want to have a quick and dirty, approach, we can use this one for very short periods of time. And very small numbers in RS, so very small mean daily returns. So this compounding approach is for longer periods of time, just like 1 year, with larger RS. So we are going to apply this one in this course a lot, but this one can be used on the short term and with small RS too. So I hope this video helped you. Thank you for listening, and see you in the next video.